Okay, so now let us take a look at this series, and the question is whether this given series converges or diverges. Okay, and so first of all, we need to figure out what is the nth term expression for this series. Okay, and apparently you know that it's going to be a fraction, and the numerator is 1. Excuse me. The denominator, we need to think about it. We have 1, 3, 7, and then 15, and then 31, 63. Okay, and turns out that it's looks like every time it seems like a double, right? So double plus 1, double plus 1, then double plus 1, double plus 1. But when we try to write it into the general situation series, you can see that anytime you make things to be a double, you're going to have something like 2 to the power n. Okay. But when our n equals 1, so 2 to the power 1 is 2, but I need a 1 here. When n equals 2, I have 4, but I need a 3. When n equals 3, I have 8, but I need a 7. It looks like we need to add a 1. We need to minus 1, and then that will complete this an. So you can verify that when n equals 1, it's 1. When n equals 2, it's 2 squared minus 1, which is 4 minus 1 is 3, etc. Okay, so it turns out our series here is 1 over 2 to the power n minus 1. Okay, and in this problem, I can use the limit comparison test for this problem. You can think about it this, when our n is becoming very large, and then it looks like my original series is going to behave very, very close to this series, right? As n is becoming extremely large. When I write this arrow, really what I'm trying to see is limit as n goes to infinity 1 over 2 to the power n minus 1 over 1 over 2 to the power of n, which is limit as n goes to infinity 2 to the power of n over 2 to the power n minus 1. This limit is going to be 1. Okay, going to be 1. And I know that both of them, they are positive. Okay, so based on the limit comparison test, both series, they are either converge or diverge. And we actually know this series very well, because this series, if I write a little bit more here, you will realize that this is a geometric series with common ratio r equals 1 over 2. Okay, so for the geometric series, as long as the absolute value of this common ratio is less than 1, apparently this is less than 1, then the geometric series, it converges. Okay, converges. So since this series converges, and based on the limit comparison test, we get the conclusion our series here also converges. Okay, so we get that this series actually it converges. So the flow chart here is anytime you have a series, first of all, write the general expression for an, and then on top of that, you're starting to choose which test you want to use. And in this problem, because 1 over 2 to the power n minus 1, we can link to 1 over 2 to the power n very easily, right? And then we also know that the limit of both two parts is equals 1, and this is a geometric series with common ratio is 1 over 2. It converges. So based on the limit comparison, the series converge. Okay, so that's the flow to solve this problem. So I hope you enjoyed this short video, and thank you for watching.